We'll be talking about the inverse of quadratic functions. We have already done inverses. We did it with linear functions. All right, so today we're doing quadratic, so it should look kind of familiar. What did I tell you to remember when you hear the word inverse? Yes, it is a -1. So f of -1, and then there was something else that you had to do every time you heard the word inverse. Switch and y, yeah, switch the x and y.
Blue's your favorite color this week, huh?
I guess so. Alright, so when you hear the word inverse, switch the x and y, and you have to remember the notation here as a little -1.
Wait, so that the notation is okay.
The little -1. Alright, number 1, graphing. No, it's going to be different. On number 1, if you're talking, quit. On number 1, what is the vertex? Close. 0, 2. Yep, 0, 2.
Oh, because it's 0 in the C.
Yeah, so there is no C value here, so 0 for the C, and then the D value is 2. What is the 3?
It's the A.
The A value. So the A value is 3. Alright, so I'm going to plot this, 0, 2. My A value is 3, so I'm going to go up 3 over 1, up 3 over 1. Remember, you cannot go past that, though. Alright, you're just plotting those 3 points. So, alright, and over here on this table, I'm going to plot some of these points. 0, 2. 1, 5, and -1, 5. Those are the 3 points that I found. We're not going to fill the whole table out. Just the 3 points. Alright, so there's my regular function f of x. So for the table of the inverse, what do I do with the x and the y? Very good. So switch the x and the y. And so now I'm going to plot these, and I'm going to graph the inverse. I'm going to graph it with a dotted line. I'm going to plot 2, 0, 5, 1, 5, -1. And graph it with a dotted line. Angie, paying attention?
Yes, I am. These are following the
Alright, so I have this sideways U shape now. Which makes sense because remember, one of the properties of inverses is that they're going to reflect across the diagonal line y equals x. So you can see this guy kind of reflects across the line there. Alright. Is the inverse a function? So we're going to test it using my vertical line test.
Oh, there can't be 2. No.
Right, and so how many times does it hit the graph?
Twice.
Twice, so is it a function?
No.
No. So it cannot hit your graph more than once.
So x can't repeat?
X can't repeat, and it repeats right here, 5, 5.
Oh, I see.
Alright, so your answer is no, it's not going to be a function. Now, because all of my quadratics are U's, and when you do the inverse, they're going to reflect and they're going to be sideways U's, are the inverses going to be functions?
No.
No. So the inverses of these quadratics are not going to be functions because they're going to be sideways U's. Alright, I'm going to do the domain and range and interval notation. Alright, so for the domain of the original, so the domain of this guy right here, how far left do you go?
-1.
And then how far right? Very good. For the range, how far down?
2.
2 with a bracket because it's a point, and then how far up? Very good. Alright, now let's look at the inverse. Alright, so now we're looking at this guy. For the domain, how far left do I go? 2 with the bracket because it's a point. How far right? Infinity. Very good. And then for the range, how far down?
Negative.
Very good. Negative infinity. And how far up? All right. What do you notice about your domain and your range?
The domain is the range and the range is the domain.
Right. They flip, which makes sense because the domain are the x values, the range are the y values, and when we're talking about inverse, x and y switch. So it only makes sense for your domain and your range to flip as well. Okay. Number 2, I made a lot of boo-boos on these notes, so this squared here is supposed to go on the outside. Alright, where's my vertex at? Close. Closer. Wait, who said it?
-3.
Yes, -3, -1.
Inside is negative.
Make sure you don't forget to switch the inside. Inside stuff is opposite. And then what's my a value?
2.
2. So I'm going to plot -3, -1. My a value is 2, up 2 over 1, up 2 over 1. Hi Chris, what's up? Oh, okay. Alright, draw your U. I'm going to plot the points I found. I found -3 and -1. I also plotted -4, 1 and -2, 1. Okay, so when I do the inverse, what do I do with my x's and my y's? Switch them. So -1, -3, 1, -4, 1, -2. And then I'm going to plot it. And so I get another sideways U. So not crossing or not passing the vertical line test. So once again, not a function. All right, for the domain of the original, how far left? How far right? Very good. For the range, how far down? 1. And then how far up? Very good. All right, so you don't even have to look at the graph to figure out the domain and range of the inverse. What is the domain of the inverse going to be? Very good. -1 to infinity. And what's the range going to be? Very good. All right, the reason why I wanted to put these both in interval notation is because I want you to start noticing something. Look at your vertex, look at your range. What do you notice? The y value is here and here, right? Okay, jump over here. Look at your vertex, look at your range. What do you notice? The y value is here and here, right? So the y value in your vertex is going to tell you what the number is in your range because the vertex is telling you where your graph is stopping. Does that make sense? All right. So the vertex is super important. All right. Jump down to part C.
Nails. Wonderful.
Oh, thank you. Yeah. All right. She just noticed my nails.
You just noticed that? Yes.
All right, so part C, we're going to find the inverses algebraically. I think this was one of the more difficult things I think people missed on the test and stuff. When you're doing the inverse algebraically, the first thing you do is to interchange x and y. So switch x and y. That's pretty standard. So this is going to become an x, 3/4. This is going to become a y.
So
Lily, is that a phone?
what?
All right, so switch x and y. And now we need to get y by itself. So this is when reverse PEMDAS is going to come in handy because it kind of tells you what to do. Because we're solving, we're going to be reversing PEMDAS. So you're going to ask yourself, on this side, because we're trying to get y by itself, what are we adding and subtracting? The 12. So I am going to add 12 to both sides, because that's what I get rid of first. Now you can't combine x plus 12, so you just write it as x plus 12. Okay, next. What are you multiplying and dividing?
3/4.
The 3/4. How do you get rid of a fraction? By what?
What's in
Very good. The reciprocal. Reciprocal.
Did I say radical?
Yes.
What's a radical?
One of the roots. Alright, so you're going to multiply by the reciprocal 4 over 3, and if you do it to one side, you have to do it to the entire other side.
4 is 48 divided by 3 is... I'm too lazy.
Alright, so on this side I get y squared. Over here I'm going to multiply this out, which you can do without a calculator. I have complete faith in you. 4/3 x. Alright, when you're talking about fractions, bottom number divides, top number multiplies. It's sometimes easier to divide first because it keeps your numbers small. So
16.
what's 12 divided by 3?
4.
4. What's 4 times 4?
Oh. What?
Alright, bottom number divides, top number multiplies. So 12 divided by 3 is 4. 4 times 4 is 16. And if you did it the other way, 4 times 12 is 48. 48 divided by 3 is 16. It's just bigger numbers. Alright, we're not done yet though because y is not by itself. So last step is to get rid of the exponent. How do you get rid of a square?
Square root on the other side, right?
Square root. So we're going to square root. And you have to square root the entire other side. So make sure your square root goes over everything.
I got you, bro.
Alright, so square root, square cancel. I'm just left with y. When you square root, there is a symbol you have to put. You have to put the plus minus sign in front. Every time you square root, you have to put the plus minus sign. If you do not put the plus minus sign, I will count off on a test.
Why?
Because
It could be a positive or a negative.
it could be positive or negative. If you think about in general, what is negative 3 squared? Positive 9, right? What is 3 squared? Positive 9. So we don't know if this is going to be positive or negative. It could be either one. And then also, if you're talking about it graphically, do you know how you have the sideways U? Okay. The top part, that's your positive part of the graph. The bottom part, that's your negative. Does that make sense? So if you're graphing it, your calculator can't graph that because it's not a function, but if you graph the positive version and the negative version, it will give you your inverse function, the sideways U. So when you get plus minus signs, that's kind of telling you, hey, it's not a function because you're going to have the sideways U-shape looking thing. So no, not a function. You have that plus minus sign. But it's also why you need the plus minus sign, because if you don't have the plus minus sign, then you don't have the right function. Okay, moving on. Number 4. I made another boo-boo. I don't know why my squareds, bless you, aren't on the outside, but I guess I just either missed it or the computer did weird things. But my squares are supposed to be on the outside. Alright. So, I want to find the inverse. What's the first step?
Switch the y and the x.
Switch the y and the x. So this is going to be an x. 2 y minus 1 squared plus 1?
Yep.
Alright. Remember we're using reverse PEMDAS. So what do I do next? Subtract the 1. So subtract 1, subtract 1. X minus 1 equals 2. Y minus 1. And then the squared on the outside. Okay, Christian, what do I do next?
I'm sort of a bit ahead.
You're ahead?
Yeah, like
Alright, well then look here. What do I do next? I just did the adding and subtracting, so what's the next step?
divide
By what?
2.
2? We're going to divide by 2. All right, x minus 1 divided by 2. 1 minus 1 squared. See, Evelyn, what's next? Square root? Yep, square root. Square root. When you're square rooting, make sure your square root goes over everything. So it needs to go all the way down for your fraction, all the way back up, and then over it. All right, so make sure your square root is big enough. Every time you square root, you need to put what sign, Andrew? Plus or minus. There you go. Plus or minus. So every time you square root, make sure you put a plus or minus sign. Okay? And Quaternion, what's the last step? Yes, you do.
Isn't it so bad?
You
Add one.
It's going to be outside the square root.
That's okay. All right, so, and yes, it is going to be outside the square root. Faith is correct because the 1 was not being rooted. So the plus 1 is going to go on the outside of your square root. Okay, is this a function? No.
So anytime
Never ever.
square rooting, it's not going to be a function.
Anytime you have a plus minus, it's not going to be a function. So you could have a square root be a function, but if it has the plus minus sign, it won't be a function.
Interesting.
All right. On the back. All right, I'm going to go down to the bottom because I'm going to draw some pictures.
We're drawing?
Pictures.
This isn't art class.
All right. As to this point right now, I have told you that the quadratic is the inverse of the quadratic is not going to be a function because you have the sideways u, right?
Yeah.
Right.
Unless you restrict your domain.
What does that mean?
I'm going to tell you.
Okay.
So on this one, we are going to be restricting the domain so the inverse is a function. All right, so here is f. This is the inverse.
Can you draw this?
Yeah, I would. All right, so just like you have a plus minus sign, you have two parts of this graph. This part is going to be the negative side because it's the negative x's. And so if you're talking about the inverse, it is going to be the negative y's. All right. This part are the positive x's. And so if you're talking about the inverse, it's the positive y's.
Did you use two separate colors?
I did, but I picked
It's
poorly
really
chosen
boring.
colors. So if we restrict my domain of f to either just the negative or just the positive, then the inverse will be a function.
So you only do one.
Yeah. So you're only going to do one. You can do either one. You can pick either doing the restricting the negative side or restricting the positive side. It's not going to matter. You'll either get the positive part of the inverse, which would be a function, right? Because you're not crossing it more than once. Or you would get the negative part of the inverse because it's not crossing more than once.
Understand.
Right?
Why did you circle those two?
Even right.
When you restrict your domain, you're either going to restrict the negative part or you're going to restrict the positive part. Go to the restroom? Yeah. And that will make the inverse a function. So if you are given a problem and it asks you if the inverse is a function and it has a domain restriction, you need to be careful about automatically saying no. Because if that domain restriction is only the positive or only the negative, then it's going to change your answer. Okay? All right, let's look at number, I'm going to do number 6 first. All right, so I want to restrict the domain of the quadratic for the inverse to be a function. All right, so first, tell me what the vertex is.
A 0, 2.
0, 2. All right, so for my graph here, it doesn't have to be perfect. We're just going to sketch it out. It looks something like this. It starts at 0, 2. It doesn't matter. Do we want to restrict the negative or the positive? Which one do I want?
Negative.
Negative. Okay, sure. So we are going to have the negative side. So if I want to restrict my graph so I only have the negative side, what is the domain going to be?
Negative infinity, 0.
Very good. Negative infinity all the way to 0. What is the range going to be? 2 to infinity. Does the range change?
No.
No. So the range is not going to change. You're still going from 2 to infinity in the original and in the positive and the negative side. So range isn't going to change. It's the domain that's going to change and have a restriction. All right. So if this is the domain and the range of the inverse, of the original, what would be the domain and the range of the inverse? So you just swap it. Good. So the domain of the inverse is going to be 2 to infinity, and the range is going to be negative infinity, to 0. Does that make sense? And if you're talking about the graph of the inverse now,
Is that all you do, or is that
that's it.
So is it?
like that's the answer?
Yeah. So the domain restriction there would be the answer, and that would make it a function. There's a lot of different questions they can ask about this, so it's more the concept than like question answer type problem. It's more the concept of restricting the domain of the function to make the inverse of an actual function. So that's more of what you have to understand.
What? How do you graph it?
Okay, so if you graph it, right, my domain is going from 2 to infinity. So I know I'm starting here at 2 and I'm going to infinity, but I picked the negative side, right? My range is going from negative infinity to 0. So the negative side is going to be down here.
So, but it's.
Oh, because it only goes
Because
up.
it's going to be the bottom part of the U. The negative side is going to be the bottom part of the U. The positive side is going to be the top part of the U.
So is there a second part to it or no?
Nope, that's it. That's it.
It doesn't have to be a function.
This is a function.
No, like the 235 like
Wait, say that one more time.
you add the second part and that's the
Yeah.
Right, but we're not adding the second part because I restricted my domain to only be that first part.
So when you restrict the domain, do you make it 0? Is that 0?
Oh, okay, good question. So for the domain, when you're restricting it, why is this 0?
Because it doesn't go past 0 for the domain.
Right, but this is probably
It's on the y-axis.
it's on the y-axis. Okay, let's do this one, and then maybe it'll make more sense.
So,
It's not like it's not making
Was that
sense.
the
It's just
vertex?
yes, there you go. That's the vertex. I didn't know how to ask it without giving away the answer. Yes, the 0 from your domain restriction is the x value from the vertex because you're using all of the values all the way up to the vertex.
Understandable.
Okay. Let's do number 7 and then I'll be done. Once again, I made a mistake. The square is supposed to be on the outside.
we're not doing 5?
No, we're not going to do 5. No, we're not going to do 5. All right, so what is the vertex of number 7?
3, 0.
3, 0. Okay, so I'm going 1, 2, 3. So it's somewhere over here. And on this one, I'm going to go ahead and do the positive one just for something different. So I'm going to restrict it to the positive side.
Oh God.
All right, so if I want to restrict the domain to the positive side of my quadratic, what is the domain going to be?
3, positive.
It's 3 to infinity. Yep. 3 to infinity, the domain. And also, that's matching up there. What is the range going to be? 0 to infinity. All right, so then when we're talking about the inverse domain range, what's the inverse of the domain going to be?
0.
And what's the range? Very good. And so if I were to graph this guy, your domain is going from 0 to infinity. Your range is going from 3 to infinity. And you have the top half of the u because it's the positive version. So domain, you're going left all the way to 0. Range, you're going down all the way to 3. So that's why we're starting here at that point. And then we're going that way.
So 3.